We're going to continue the previous video by adding a unit to our installation that can supply the cooling required by the different air-conditioned spaces. Before this, we create a new section view that allows us to observe the interaction of our ducts and grills and the architecture, which is essential to check the feasibility of the solution. We also provide the new unit with heating support functions, which allows a reduction in the number of radiators if necessary. This will be done in a drastic way. We'll remove all radiators at the bottom of the screen. Next, we compensate for the loss of these elements. We do this by incorporating a ducted fan coil connected to our generator. To do this, we define a generic library element. A 14.4 kilowatt fan coil should cover our needs. Once defined, we can place it on the suspended ceiling at a height of 2.6 meters in one of the service spaces. The program allows us to check its placement in the section view. Next, we need to define a duct library element. We also define some grills. We are going to define rigid fiberglass ducts. We import some supply grills from the library. In this case, we incorporate the whole series. Once these elements are defined, we can start modelling. We trace the duct axis on plan, starting from the fan coil outlet and running along the entire band of circulation and service spaces. The different branches will depart from this main branch. We deactivate force elevation to snap the fan coil connector. As with the pipe diameters, we do not have to define sections. The program will analyse them and assign them to the different sections. We make a couple of connections per room with a final vertical section of at least 40 centimeters, with enough space to be able to solve the fittings and possible reductions up to the final grill. The grills must be placed at the ends of the ducts, whether they are horizontal ducts with a vertical grill, or in our case, a horizontal grill on the end of a vertical duct, a horizontal grill that may require the creation of a false beam in the architectural model. We select a 300mm by 150mm grill. The individual branch can be copied to different positions, using the architectural reference as well as the layout assistance and possible dimensioning. In this case, we'll make a somewhat free arrangement of these branches. We have defined the duct layout, but we have not yet connected the fan coil to the roof generator. We simply connect the corresponding inlets and outlets with pipes. Considering that we have the supply and return connections that supplied the radiators, we can use them to connect our fan coil, while always respecting the directions. The supply, in dark red, is connected to the inlet of the fan coil. The return, in a lighter colour, is connected to the outlet. The connection can be carried out directly on a 3D view, which allows us to ensure that the connections are correct. We can now carry out the analysis. After the analysis, we find some errors and warnings. The main one is determined by deactivating the cooling functions of the heat pump. This mode must be activated. Once this issue has been corrected, we return to the analysis. We can see that the correct colours are assigned to the pipes: red for heating, blue for cooling, and green for both heating and cooling. The ducts have not only been designed, but the program has also generated all the necessary connections, branches, elbows, transitions, etc. We can see that the thermal load errors have disappeared. The radiators supply heating power that is supplemented by the flow provided by the various grills fed by the fan coil, which operates autonomously for cooling. The application is responsible for distributing loads and assigning the corresponding loads to each space, depending on the location of the terminal elements. We only have one warning for the water temperature. 60 degrees is too high for a low temperature system. We can try lowering it to a more reasonable 55 degrees and then calculate. The warning does not disappear, but in this case it seems acceptable and manageable. As always, in addition to generating the traditional documents, drawings and reports, the program allows the model to be exported to our shared project so that both the model and the results are readable from the cloud. This way, they can be checked from any device connected to the internet. The generation of ventilation systems will be the same as for air conditioning. The use of fans and heat recovery units, among others, will allow the detailed definition of this type of system, which, once analysed, will be colour-coded according to ASHRAE.